This diagram represents the pH scale. We will talk more and more about the pH scale as the series of videos progresses. Right now we need to understand that the pH scale is simply a representation of the hydrogen ion concentration in a solution. In a typical chemistry class, the pH scale will range from 1 to 14. In extreme cases, you could get pHs that are less than 1, less than 0 even. They could be negative. You could also get pHs greater than 15. But that's not going to happen in a typical chemistry class. Notice that pH values from 1 to 7 represent acids, while pH values from 8 to 14 represent bases. Neutral substances would have a pH of 7. That's very hard to achieve in a laboratory setting, so for this class, we are going to say that a pH of 6.5 to 7.5 will count as a neutral substance. So let's consider some acids, bases, and neutrals. Remember, an acid is a substance that donates a proton or an H+ ion to solution. If you look at some of the strong acids here, sulfuric acid is a strong acid. You'll notice all three of these strong acids listed have hydrogens to start their formulas. That is pretty typical. If it's an acid, the hydrogen will be at the beginning of the formula. Sulfuric acid actually has 2 hydrogens. You can see the beginning of hydrochloric acid and nitric acid all have that H+ ion, which would be donated to solution. If there is an organic acid, you're looking for that COOH functional group or that carboxylic acid functional group. So for organic acids, typically the hydrogen that is donated is at the end because that COOH functional group is written at the end of the formula. So for acetic acid, for example, nitrous acid, it has its acidic hydrogen at the beginning of the formula. Aspirin has a lot of hydrogens, you can see there, but we can see right there in the upper right there's a COOH functional group. That's where the acidic hydrogen will come from. Citric acid has 3 acidic hydrogens because it has 3 COOH groups. So each one of these hydrogens could be donated to solution. We have here a list of neutral substances. The most common we'll use in the lab is distilled water, but some organic solvents and alcohols and oils will also have neutral pHs. Let's look at some base examples here. Base, remember, is a proton acceptor. Typically, bases will have a hydroxide ion, OH-. OH- will react with H+ to form water in the acid-base neutralization reaction. So the OH- will accept the proton. So in some bases, you will see that OH- hydroxide group in the base. So NaOH, KOH, they have OH-. MgOH, you can see the OH-. Anything with that hydroxide group is going to be a base. Now, it doesn't always have to be a hydroxide group. For example, sodium bicarbonate is a base. It will accept a proton in solution, but it doesn't have that OH-, that hydroxide group. The best test for all 3 of these substances is to simply test the pH. Whatever pH value you get, you can compare it to the pH scale to determine if that substance is an acid, a base, or a neutral.